All right, let's get right into it. Today, we're going all the way back to the beginning, to the document that kicked this whole thing off, Satoshi Nakamoto's 2008 white paper. We're going to break down the revolutionary idea behind Bitcoin straight from the source.
So, here's how we're going to tackle this. First, we need to understand the big problem with digital money that nobody had really solved yet. Then, we'll dive into Satoshi's incredibly elegant solution. After that, we'll see exactly how the blockchain works, piece by piece. We'll meet the people, or, well, the computers, that run the whole network. And finally, we'll look at how this system is still changing today.
Okay, first up, the problem with digital money. You know, it's something we don't even think about anymore. Before Bitcoin, every single thing you did online with money, buying something, sending cash to a friend, it had to go through a company, like a bank or PayPal. There was no other way.
And that really gets to the heart of the question Satoshi was trying to answer. How can you and I send money directly to each other online? Like handing over a $20 bill with absolutely no one in the middle. The whole problem, it really just boils down to one simple thing: trust.
This is Satoshi's big critique of the system we all used. You've got banks in the middle, and that drives up costs. And because they can reverse transactions to handle disputes, you can never have a truly final irreversible payment. This makes merchants nervous, so they ask for all sorts of personal info from you just to protect themselves. And you know what? A certain amount of fraud is just baked into the system. It's just seen as the cost of doing business.
All of this brings us to the main villain of the story, the double spending problem. I mean, think about it. With a physical dollar, you can't give the same bill to two different people. It's in one person's hand or the other's. But a digital file? You can copy and paste it 1,000,000 times. So how on earth do you stop someone from spending the same digital coin over and over again? This was the absolute core puzzle that Bitcoin had to solve.
So that's the giant problem hanging over digital cash. Now let's get into Satoshi's radical solution, a system that's not about trusting people or companies, but about trusting pure, verifiable proof.
This quote, right here, from the paper itself, is basically the entire mission statement. This is the whole idea in one sentence. What if, instead of relying on a bank's promise, we could rely on math, pure cryptographic proof? That's what would let us finally cut out the middleman and pay each other directly.
And this just lays out the massive change in thinking perfectly. The old way, it's all about trusting institutions. The new way, it relies on a network of equals, of peers. You go from reversible transactions that need trust to transactions that are basically impossible to reverse because they're locked in by math. It's a total flip of the script.
Okay, so this cryptographic proof sounds great, but how is it actually built? How does it work? Let's get into the guts of the machine and build this thing from the ground up.
Believe it or not, it all starts with a pretty simple idea. The white paper says an electronic coin is just a chain of digital signatures. To give a Bitcoin to someone, you basically sign it over to them electronically. It creates this public, verifiable chain of who has owned that coin, kind of like signing the back of a check to pass it along to the next person.
But just having a signature isn't enough to stop double spending. You need a public history that everyone agrees on. So transactions are gathered together into these groups called blocks. Now here's the magic trick. Each new block contains a unique digital fingerprint, a hash, of the block that came right before it. This is what links them all together into a secure, unbreakable chain, the blockchain.
So how does this global network of computers agree on which block is next? Well, Satoshi laid out these 6 steps. First, new transactions get shouted out to everyone on the network. Computers, or nodes, collect these transactions into a new block. Then, they all start racing to solve a really hard math puzzle. The first one to solve it gets to broadcast their block to everyone else. The other nodes check their work, make sure all the transactions are legit, and if it all checks out, they accept it and start working on the next block in the chain. That's how everyone stays in sync.
And that really hard math puzzle? That's what we call proof of work. The genius of it is that it's incredibly difficult to solve, but super easy for anyone else to check if the answer is right. To create a block, you have to burn real-world resources, your computer's time and electricity. Satoshi said it's like gold miners spending energy to pull gold out of the ground. This work is what makes the chain so secure, because to go back and change an old block, a hacker would have to redo all that work and all the work for every single block that came after it. It's practically impossible.
So we have the how. We understand the mechanics. Now let's talk about the who. Who are the participants that actually make this whole network come alive? Well, that would be the nodes and the miners. Now here's something that might actually surprise you. A lot of people use the terms miner and node as if they're the same thing, but they're really not. In fact, as the network operates today, most of the people doing the mining don't even run their own full node. And this table really clears it up. Here's the best way to think about it. The full nodes are the referees of the game. They download every block, check every transaction, and they enforce all the rules. The miners? They're the players on the field, doing the heavy lifting, the proof of work, to create the next block. So the nodes are the rule enforcers, and the miners are the block creators. They keep each other honest.
Now, over the years, mining has gone from something you could do on a laptop to a full-blown global industry. Today, most of the network's computing power is concentrated in these huge mining pools, where thousands of individual miners team up. They pool their power together to get a better shot at solving the puzzle and then split the reward.
And you know, this concentration of mining power is a perfect example of how the system has changed over time. And with that evolution comes new challenges, things Satoshi might not have seen coming.
A huge part of this evolution was a straight-up hardware arms race. I mean, it started with Satoshi's idea of one CPU, one vote. This really democratic vision. But pretty quickly, people figured out that powerful gaming graphic cards, GPUs, were way faster. Then came even more specialized chips, FPGAs. And finally, ASICs. These are chips designed to do one thing and one thing only, mine Bitcoin at insane speeds. This completely changed the game, turning a hobby into a massive, expensive business. And with this rise of industrial-scale mining and these massive pools, one number becomes really, really important: 51%.
Look, the entire security of Bitcoin is built on one big idea, that no single person or group controls the majority of the network's power. If someone did manage to get control of 51% of that computing power, they could, in theory, start rewriting history. They could create their own version of the blockchain faster than the honest network, letting them reverse their own transactions and, double spend their coins.
So if there's no CEO, no board of directors, how does a network like this deal with big challenges and make upgrades? Well, the answer is this process called Bitcoin Improvement Proposals, or BIPs for short. It's the community's way to suggest, debate, and eventually implement changes to the rules of the network. It's how a leaderless system manages to adapt.
Okay, so let's just quickly recap the big ideas here. Bitcoin's genius was solving that double spending problem without needing a bank. It's secured by that public ledger, the blockchain, using proof of work. The whole network is kept in check by two different groups: nodes, the rule enforcers, and miners, the block creators. And finally, this isn't some static thing. It's a living system that's constantly evolving to deal with new challenges. And that brings us to the final big thought. Satoshi's white paper proposed a fundamental trade-off. It asked us to shift our trust away from human institutions and put it into cold, hard, impartial code. And as this technology keeps growing, the big question we're all left with is, what is the future of that trade-off? Thanks for joining me on this deep dive.